Welcome to the Web Platform Podcast, episode number 118, Understanding GraphQL. And on today's panel, we have Justin Rivero.
Hello, wonderful people.
Myself, Eric Isaacson. And we have some guests today. If you guys want to introduce yourselves, just say a little bit about yourselves, starting with Corey.
Yeah. Hey, I'm Corey. I'm a developer in the DC area. I work for a fast casual restaurant that people in like Maryland, DC, and Virginia probably only know, called Kava Grill. We write mostly Elixir, React, Redux, and are starting to explore GraphQL.
And Ben?
I'm Ben Wilson. I work for CargoSense. We're a logistics intelligence in the logistics intelligence space, and we're based in the DC area. And we've been using Elixir in production for about 3 years and GraphQL for about a year. So it's been a lot of fun.
You're veterans, over a year in production.
Yes, something like that.
That's amazing. That's awesome, actually. So, what is GraphQL? We brought you guys on here to talk about GraphQL and what it's about. There seems to be a lot of hype around it, especially in the React community. So why use this over other solutions, like REST or SOAP, and what exactly is it?
Yeah, so by way of illustration, so our particular, we came to GraphQL because in our particular, in our domain, we have lots of little applications we had built that suit a very particular role. So we've got people in warehouses who are trying to put sensors on stuff as quickly as possible. So we had to build something that was very streamlined for that use case. That's a very different use case than someone, the logistics head who's looking at the sort of 30,000 foot view, and we had stuff built for that as well and everything in between. What this had given us as we were building REST APIs was this wild proliferation of often very redundant, but always slightly different REST endpoints, because we needed to be able to get the data that was important to these different roles out in an as efficient way as possible. Many of them were running on cellular networks and so on. And so that meant we had our REST APIs, instead of being these lovely generic endpoints that that you think you can make, those often require a lot of linking. And so to actually get all the resources you want, you're following, a dozen different hyperlinks. And that gets very expensive as far as time and battery when you're using cellular devices. So we were intrigued by GraphQL because we thought we might be able to sort of limit the proliferation of code we had on the back end and also optimize for the clients. And GraphQL lets you do that because it's a spec in and around building a document that articulates the data you want, and some tools on the server side to get you exactly that data. And that's basically what it is, and that's what we've been using it for to great success. So we were able to collapse a half dozen different REST APIs, including some our customers were using who'd never heard of GraphQL, and that's all chugging along great now. So.
Yeah.
And how does it differ, though, from REST or SOAP or other solutions that you've seen?
So comparisons with REST and SOAP are, we'll go with interesting, because they're all slightly different things. Like REST is almost more of an architecture than like certainly a spec in and around request response format or something. SOAP is actually slightly more the same kind of thing as GraphQL, because they had a request format and sort of structure there. So GraphQL is transport agnostic. So you can do it over HTTP, you can do it over WebSockets, you could do it over email if you were a madman. It's really just about the request format and then the invariants that get held about that. So it's like, we're going to make sure, here's what it means to have a valid document with respect to the schema of information that the server says you can ask for. So it's different from REST in that it really is not using any of the RESTful principles. If you're using it over HTTP, you're basically just posting everything. Whether you're getting data, it's a post. Whether you're deleting data, it's a post. And this is because it maintains its own notion of the sort of graph of information you hold, and it has its own model for what it means to get information or to mutate information in that graph. And so that that model is what you're using instead of your familiar HTTP verbs. That's really just a means to an end as far as transporting that information goes.
Yeah, I think the classic example is to say, like, if you were using a REST API and you were doing like your typical blog, and you want to get the blog post, the author on that blog, and then the comments, you would probably make a request to blogs for an index, find the IDs that you need, make a request to that specific blog post to get the information. Whereas GraphQL, you can be a lot more specific and just ask for all the blogs with all their information. And you can also exclude data. Like if you don't want the actual blog post body, you can not ask for it and you won't get it back.
Right. So for example, to elaborate on that example, oftentimes if you're building a very, in a lot of people's idea of a correct REST API, if you get the post, it's going to have like a link to the author, and then you do a second request to go get that author, and same with its comments. They're not going to be in that document. If they are in that document, you've got the problem of it's always sending you this data whether or not you actually need it. And if you don't need it, or if you do need it, you have to make all these subsequent requests if you're going the link route. So the document that GraphQL has you send specifies exactly what that is, and then it will give you exactly that.
And I've seen, GitHub, they recently had a GraphQL API added, and they're using it alongside their REST API. So it seems like you don't have to choose one or the other. It just depends on your needs for the data. Is that correct?
It's my understanding. Well, GitHub's in a position where deprecating the HTTP API would be, we'll go with a dramatic shift and a big problem for many of their customers. Obviously, at the end of the day, GraphQL is not the data itself. Your data is stored in Postgres or some non-relational database. It's stored in all kinds of different ways, and GraphQL is an API on top of that. You can always have a REST API on top of that as well. You certainly can do both, but I don't know if you're in a position of starting from scratch. I don't know of a reason why you would do both unless there was some kind of situation where you had clients that could only do it REST, and you were definitely going to have to support those clients. Then you got to do REST. But if we, for example, are doing no further RESTful APIs at CargoSense. So.
Hey Ben,
and Facebook has this. I'm sorry, Corey.
No, that's
Facebook
cool.
has this on GitHub as a spec, and I don't know what their plans are to do with that. Do you guys know kind of how that's taking shape?
Yeah, so the spec development is ongoing. Every few months there's sort of a new draft that's released. There's parts of that spec that have been very stable now for some years. I think a lot of the development right now has to do in and around their notion of subscriptions, which are when you suppose you're looking at an article, and as people are adding comments to that article, you'd like a way to say, hey, I want those things to be sent to this page so I can have them show up sort of automatically. That is undergoing a lot of development at the moment, but it's a very open process. People submit RFCs, and there's dialogue about it on GitHub and so forth. That spec is handy because it means that there's a pretty large number of implementations at this point. There's obviously the JavaScript one, Ruby, Elixir, Clojure, Scala, etc. And what's cool is that for any of those that are mature, and there's quite a number that are, if you are a client of a GraphQL API, you don't care what the underlying language is. You just send the document, you'll get a response back. If you follow the spec, all will work well.
Yeah, I would imagine that that they would want to move this to some other standards bodies at some point, like W3C or some other one that's more pertinent to APIs, maybe.
I don't know anything about that.
Okay. So can you tell us also, I know, Corey, actually, you had a question earlier. I'm sorry.
Oh, yeah, this is just to go back, talking about APIs. If necessary for kind of the transition period, you could basically put in your API requests into GraphQL. Is that right, Ben?
When you say put into GraphQL,
Sorry, kind of if you were to set up a GraphQL server, you could then call your API endpoints via it to get the data back that you needed.
Yeah, there's actually some examples online actually of things going both directions. So for example, you build a GraphQL API and you want to still have your legacy REST API available, but in the code for say a controller, you just call you build a GraphQL document that represents what would have been sent by that API, and you just pipe that through your GraphQL system. There's other things that go the other way around, where you've got a REST API and you want to sort of provide GraphQL functionality on top of that so that clients can customize what they're doing. There's also tools to do that. It hails from a domain where it was trying to be an API for many different kinds of backends. So it's very well suited to be a front end to other REST services, other GraphQL services, and Postgres. And the client doesn't have to care where that's ultimately coming from.
Right. That's what makes it so cool.
So if you're coming from a database background, or if you've used APIs in some form or shape, I mean, how does GraphQL sort of handle the world of CRUD? Like, a lot of developers at the end of the day think, of your typical CRUD operations as getting work done. I get some stuff, I post some, or I update some things, be skippy for me. How does GraphQL, take care of that?
So what's relatively nice there is that it is very operation focused. So there's the input data and the output data is all there's like concrete data types that you can introspect and so on. It's a fully typed system. But when you ask for users, that really is actually essentially a function, in the job of that function to get any kind of arguments you give it that might be filtering or whatever and return a list of users. So your CRUD operations get to focus nicely on whatever the actual operation it is that you're doing, because there's, the first things you do are CRUD, and then there's like, oh, well, I've got this, I built these things, but now I want to, put a comment on a post, or I want to like a story, for example. That's obviously a common one from Facebook. You can think of that as creating a like thing on a post, on a comment or something. Or you just have in GraphQL, you build a like comment mutation, and it returns the comment that has been mutated to be liked by somebody. So it's relative. There's tools out there that if you really want to, have the minimal amount of boilerplate, you can. The schema is a static document and static code, so you can just go use any of the normal tools that you have to reduce boilerplate in your language to go build out all that stuff if you wanted to sort of do so in a rapid way. CRUD is a pattern you can do with GraphQL. It's one that many people do, but it doesn't need to have first-class support to be easy to do. Might be one way to put it.
It's so weird hearing the word mutation and Facebook in the same sentence, because like I just feel like I've been using React lately, and I feel like you get slapped on the hand with a ruler if you try to mutate anything.
So yeah, it's by way of background, I don't really do a lot of front end code. That's other people that I work with and respect, because I'm not very good at that. But there's some interesting mutations. The reason it treats mutations with such care is, I think, a lot of the same reasons why Elixir and other functional languages treat mutations with care, in that you want to be able to model what those side effects are doing, and not just be like, this thing happened and I don't know what it changed. Like, who knows what it changed? I did this thing. And
right.
So the clients frequently put some patterns around a mutation so that when you get the data back, you know what on your screen, or what kind of data that the client's holding, you know what has been changed on the basis of that mutation, which is actually really powerful and something that you don't get in a RESTful system.
I think that's a good lead in. You mentioned Elixir in there, and you guys, I believe, use Elixir on the back end with GraphQL, and I know that you've contributed, or you own, I don't know what it is, the Absinthe project on GitHub, open source. Yes,
Bruce Williams, our CTO, and I have co-written Absinthe, and it's under its own GitHub organization, but we're very much the people behind that. So.
And can you tell us a little bit about that project and why it came about?
Yeah, sure. So first I'll mention we are actually writing a book on it. We signed up with Pragmatic Programmers, and we hope to have that coming out sometime late spring, I think. We're still pretty early in that process. But so Absinthe came about because, it was one of the first, I think it was the second ElixirConf. Chris McCord's keynote mentioned GraphQL, and that we'd heard of it before, but when he mentioned it, that really prompted us to look at it more closely. And I explained a little bit of the situation we were running into with our myriad of REST endpoints, and so it was very interesting for us. So we began working on Absinthe pretty quickly thereafter, and we had an implementation that was working in production for us a few months later. Building a GraphQL implementation is a whole lot harder than we had thought at first. And in talking to implementers in other languages, there's kind of this process where you build it once to figure out how to actually do it, and then a few months later, you scrap 90% of it and build it again now that you actually know what you're doing. And so we did that sort of this spring, and came out with a version that was not only better, but it's since we understood a lot of the essential nature of what had to go on, we were able to model things in a way that's been a lot more accessible to people. So the number of contributors involved in Absinthe has grown dramatically because I think we hit upon a way of representing what's actually going on that people can understand. So that's we're still working on the docs. We're working on all kinds of stuff. We got a fun roadmap, and that's been an exciting project for us.
Can't release it without the docs. Come on.
No. We have plenty of docs, but there's never enough. You can always have more docs.
So it seems GraphQL, it was brought to my attention earlier that GraphQL could definitely relate differently to different data stores or ORMs. How does it relate to those? Yeah,
so as I was hinting at earlier, Facebook built it because they needed an API over a multitude of different kinds of backends, and they wanted the freedom to change what kind of backend they were storing a particular data on, and they didn't want that to affect any of the clients. So basically, the secret sauce of GraphQL is that the server side has a schema, and that schema builds the graph of data in your system. People often kind of wonder, well, what's the graph mean? Well, it's that. It's a query language for querying graphs. So you have this schema. It's all your little interconnected kinds of data, and then it's the links between those points in your graph where you run totally normal Elixir code if you're writing it in Elixir code, or Scala if you're writing it in Scala. And those links are, okay, if I'm at a user and I want to get to the comments, what code do I need to run to actually go get that data? And it's there that you hit up Postgres, or maybe you're doing something fancy and in memory, and you've got, you go ask your Erlang process for something. You just run the totally normal Erlang code to sort of move between points on in your system. So it does not replace, generally doesn't replace something like Ecto, because Ecto is, it's not really an ORM, honestly. It's more of like a query DSL and some validation tools, and you would definitely still want to use those. But at the same time, there's very frequently not a one-to-one correspondence between the entities you expose via GraphQL and the tables you have in your database. A particular process may have a whole bunch of join tables that you really don't need to expose to people, because they can just, you're going to basically walk through those to get the data people want. So maybe comments don't belong directly to a post, but there's some join table, but you're going to just expose it as belonging directly, because that's from an API perspective all you care about.
So it doesn't matter so much what data backend I'm using then. So for instance, if I use like a graph database like GunDB, or if I used something like Mongo or even MySQL, like it doesn't matter as much.
Absolutely.
Okay. And are there good community projects for all those types in general? Not like specific things like Like gun, I would imagine would be something that the gun organization would build. But is there like stuff for Mongo in general, or NoSQL in general even?
Well, so a lot of that is just a question of the server side tooling. So if we have, for example, a package that provides certain ways, certain tools to help you query a ecto-backed database efficiently. So for example, people might be concerned that if you had like, I want to get a post, all the comments on that post, and the author for each comment. You might be very concerned you're going to end up with an n+1 problem getting the author for each comment. But we have some handy little tools that batch that together, because we know that ecto is a kind of thing that you can, structure a request that gets all that data. So it's many of those tools already exist for reasons that are beyond GraphQL specifically. So on the JavaScript side, there's Data Loader, which is this very fancy tool for accessing data from JavaScript in an efficient way, and people use that with the GraphQL all the time because it's a helpful tool for doing so. It depends a little bit on your language.
So sometimes, depending on that, I may have to create something, or we may have to create something to offset any possible performance implications. Is that what I'm hearing?
Not exactly. I think it's if you need a tool to access gun, say in general, then you'll be able to use that. We provide you with a whole lot of information about what kinds of things people are asking for. So the part where you have the clients are asking for a flexible amount of information does mean that you have to may need to consider that, put more thought into how you're accessing your data store than if on a REST endpoint where it's always going to return a certain amount of thing, you can just hard code all the tables you're joining, for example. And that pattern will generally not work here because you're either not going to be flexible enough. You'll never send, it's important to note that you'll never send clients information they don't ask. So for example, if you don't know a good way to select out of a Mongo document only the things you need, you can just return the whole document, and then the client, the server will filter out the things that the client didn't ask for and still send them only what they want. So there's how much performance tuning you want to do depends on your requirements. And many of those tools are, you're just going to reuse the tools you're already familiar with. Very little of it is GraphQL specific.
So really you're talking about sort of the business logic level of things, right? QL is going to return to you some set of data that you're going to possibly operate on that goes beyond it. Because it really is a thin layer. I mean, it should be pointed out, on top of either an existing database or some other structure that you have, right? At the end of the day, it requires a driver to go and say, this is the data I want to pull out of it. And how you handle that performance is sort of up to you. That's not really GraphQL's job as a whole. Right.
About the only things that GraphQL stipulates is that, if querying, it has a notion of concurrency, which is a little bit useful in that, for example, however you implement the retrieval of sibling fields ought not to be reliant on the order in which they're done, for example, because they have sort of, whereas if you're mutating data, those will always be run serially. So the spec does talk a little bit about some expectations that the clients ought to have. It's not that they're saying every server implementation must always execute sibling fields concurrently. Rather, clients ought not to expect any behavior that is reliant upon fields executing serially, and so that frees up the server to do, anything they want to optimize for performance there. But yeah, at the end of the day, it's thin in the sense that you're given some requirements, you're given some input from GraphQL, and it's up to you to go get that data. The thing where GraphQL will help make even that more performant is that you know exactly what you're looking for. So if you don't need to get a particular table, you won't get that table. If you're only getting certain fields on that table, same with that. This is particularly valuable if you're doing anything that might be have a lot of latency. So you can, and the structure of the document also makes it very easy to know when you can aggregate things, for example, because the structure that's coming in is all typed and whatnot. Obviously, with a REST endpoint where you're only going to get you only support one shape coming in, you're only going to get one shape coming out. You already have all those things. This is more just to point out that because the type system means that even when you have the flexibility, you can still keep doing a lot of that stuff. So,
yeah, I mean, from a shape standpoint, right? I mean, that's one of the more keys, right? It's because it's not that you can't shape data in a REST API. It's just that from a REST API perspective, if you've built some such, right, REST APIs generally don't allow you to shape data, right? That's not how typically you design API endpoints.
Right.
But from a GraphQL perspective, you define the shape of things based on your particular sort of model needs or whatever your data driving on the front side. So if I need to shape a particular user profile page and I need some additional things, I can shape that and not have to rewrite a REST API query that I might have to do or go request joins to be written or some such to do that, right? That's the power behind GraphQL in that regard.
Yep.
And that's what has led us to look into GraphQL, is that we use React and Redux. And basically when you land on a page, we make like 5 or 6 API requests, all asynchronously, and then we have to map over everything, filter out, reduce, and create like this application state that we then give down to all our React components, and everything's great. And I think GraphQL adds that level of transparency to be like, hey, this is the shape in which I want to call my data, or the shape in which I want to get my data back.
Yeah, and I'm new to Redux. Like I've only been using it for a few months now, and it's interesting too. Like those reducers, when the data comes in, I have to do so much data formatting and manipulating of the data. I wonder if GraphQL would help to make those thinner. Those so this way you're reducing the overall amount of code in your applications.
Yeah, I definitely think it would.
There's some interesting like development practices stuff that I think it improves as well, because if for example, when we were building a mobile application, we talked with our mobile team and we just sort of agreed on the kinds of root things that they needed, root queries that they were going to make. And then based on the sort of documents, the documents provided a really easy way to sketch out the kind of information they needed. And then for anything we didn't have already available in the back end, I went and coded that. And then our mobile team used those documents to actually generate sort of local seed data and responses. So they just worked off of the documents they thought they were going to request. And then we just were able to stick them together and everything worked really, really well. And then if they suddenly decide, oh, whoops, I wasn't getting the email here somewhere where I also need to get the email, they can just basically add that. Like so many things, both our front end teams or our mobile teams have realized they now also need, and they just ask for it. And 99% of the time, it's required no changes on the back end at all.
Yeah, I was recently, just the other day, going through this CMS that we use here internally called Contentful. And they have a REST API, but it's interesting. I wonder if they're using GraphQL without us knowing, because it was really cool for the component model where you have the one endpoint and then you have these other pieces that it could actually extrapolate just the data you need for that component or that module. So it sounds similar to like just getting the data you need. And it was really useful for a specific mobile team that we have here. I mean, they use Objective-C and not, they didn't use the JavaScript API, but I thought it'd be very interesting.
Yeah, there's also JSON API, and the JSON API is sort of this spec building in and around a sort of a REST plus some JSON patterns that give you some of the ideas here. So they want to be able to say, hey, here's stuff I want to include, here's stuff I don't want to include. The difference in my mind is largely in and around. It's all about basically just specifying like keys in your JSON that you're gonna get back or want or not want. There's not a strong, the lack of strong typing associated with this stuff really limits how far that can get you. And the amount of validation that goes into validating the kind of inputs that you have to the system are very limited as well. So a good example is a very simple one. If you were building any kind of filter that takes a date time, you are going to represent that date time in JSON as just a string, because that's really the only thing available to you. So it'll be some, RFC 3339 formatted string. But in your server, you can say, hey, this particular argument value is a date time. And so when that gets passed in, GraphQL will validate that that's actually a properly formatted date time. And if it's not, you'll get a client you'll send a response back to the client saying, hey, on this line of this request, this particular argument had an invalid value. It should be formatted like this. But then if it is correct, then in the sort of equivalent to your controller code, that thing is given to you as a parsed date time. You don't have to worry about parsing it. You don't have to worry about whether it's valid. You just have it. And that hits on, I think, one of the big differences on the server side from REST versus GraphQL is that a REST controller places the responsibility of validating the inputs in the hands of you, the controller writer. Like there's libraries that'll help you with this stuff, but basically you're given stuff that is possibly invalid, and you have to go call something that validates it, and then you get stuff that's back if it's valid, and you kind of handle things from there. And GraphQL inverts that relationship by saying your schema will declare things about your inputs that have to be true. And if they're not true, we're not going to give it to you. We'll handle that. We'll give a response back to the user that's incredibly detailed. And only if it is valid will we hand it to you, and then you can just go from there. So it's made a whole lot of the code you write there much simpler, because you can just focus on like the business things you have to validate here. You're not stuck making sure like, oh, well, did they give us an integer for the ID or a string by accident? None of that stuff you have to worry about, even with much more complex types like date time, like lat long coordinates, whatever you want. You can make up arbitrary data for that kind of thing.
And for the consumption of components also with microservices and things like that, is that something that GraphQL is like in opposition to or works well with?
They're somewhat unrelated in the sense that one way in which it's very helpful is that the standard way where GraphQL doesn't really care what the ultimate backend is, right? You could have many different microservices, each handle some particular chunk of your data. You could provide a common GraphQL API that goes over all of that. And I don't know where that lands on is it friendly to or unfriendly to the microservices paradigm, because by having a GraphQL service in front of all your microservices, you're sort of hiding the fact that they're separate services. Alternatively, you can make each of them a GraphQL-based service. They could send GraphQL docs to one another. And what's actually a little nice there is that as far as development tooling goes, you have access to each of these things' schema. So there's tooling, for example, that will help you validate in development and at compile time that queries you send to different services are in fact valid. So you can catch a lot of stuff much earlier. So I don't know. I think it's a tool that can be used in a microservice architecture. I think that really the only thing that it brings to the table more directly related to that is the frequency with which people are using it to as a common API surface over perhaps a multitude of microservices. I don't know. I don't have a lot of experience with it in that context. Maybe someone else can add more to that. Not my area per se.
Nope. Yeah, I think one of the things for me too is a lot of time we're doing not here at Carfax where I'm at as much, but a lot of times as front end developers we're pulling in APIs. Some of them are in real time, right? So in real time you have stuff like Firebase, and you have streaming data, WebSockets. You're probably using HTTP 1 versus HTTP 2. And how does GraphQL work with those types of transports?
Yeah, so to tie those together, actually, it occurs to me part of the reason that like the microservices in Elixir is sort of its own interesting question, because the notion of an Erlang application gives you some of the independence and structural things you want out of a microservice architecture without necessarily requiring that they're separately deployed entities. And so we, for example, have a number of separate Erlang applications that manage particular real-time properties that's separate from our standard Postgres database. And we do provide a single GraphQL API over all of that. But it feels a little bit different than I think what a lot of people are talking about with microservices, because they aren't separately deployed entities. But so on that real-time thing, for example, I touched on earlier that the GraphQL world is developing this notion of subscriptions. And just in the same way that a regular GraphQL query is transport agnostic, so is the subscriptions thing. But a lot of people are, of course, using WebSockets because that's a natural way to get streaming data. HTTP2 is not something I'm an expert on by any means, but it's the way it can handle longer connections is, I think, also relevant. So to actually put some of these things in a more concrete thought, GraphQL can give clients a relatively interesting amount of control over not just what data they want, but how they want it. So suppose, for example, you want to get, you're going to go to a page that shows an article and comments. Well, it matters most that the body of the article and the title and so on show up as quickly as possible, because that's the thing that is immediately in front of you. So GraphQL has a thing called directives, which are just sort of annotations you can put on a document. And one of those directives might say, hey, I'm going to defer the comments. And so what that lets you do is the HTTP connection will send the non-deferred chunks, so the body and the title and maybe the author name or something, immediately. And then the front end can like display it, it gets that data, displays it. And then the comments are sent in subsequent HTTP chunks. So that way, it's, especially in bandwidth limited contexts, you get the most relevant information as quickly as possible. And then you don't have to wait on the entire body to move across the wire to begin showing useful information. So there's that kind of stuff is already built, developed in and around the HTTP1, HTTP2, kind of the options those give us for transports. Subscriptions are a way to extend that to a sort of long-held, persistent relationship between a client and a server. But the distinguishing characteristic of those are their relationship to change. So if I get some information and then I change some data, there's always a GraphQL mutation has a response associated with it. And what you ask for in that response is going to be the data you want to have sort of refreshed on the basis of whatever change you made, which makes sense. So if I add a comment, it'll just be that comment. If I like a story, I might want that story, the whole story back, because the like count will be different or something. A subscription is listening to other people's changes, which is actually a really interesting way to think about it. So when you create a subscription, you're specifying the information that you want to be sort of sent to you in its updated state on the basis of other mutations that people are making into the system. So in our comments example, you would subscribe to comments, and that would be triggered by someone mutating the graph by creating a comment, and then that will get published to you because that's the kind of mutation you're listening for. So that's what subscriptions are, and they are definitely, I'd say, getting the most use out of the WebSocket transport. We're right in the middle, actually, of adding that functionality to Absinthe. It's not live yet, but we hope in the next couple of weeks to have that squared away. We're using a sort of prototype version of it for some of our own stuff, but we hope to get it to a public state soon.
That's pretty awesome.
Are those subscriptions common in other GraphQL implementations?
They are, but every one of them is in a very prototypical state right now. So for example,
Gotcha.
Apollo server has one, and there's a number of very interesting performance challenges to consider. So for example, suppose the subscription includes, you want the author and name. Well, if there's 1,000 people looking at an article and someone creates a comment, in the Apollo server version, you're going to do 1,000 database requests because you're running each of those documents, separately. And that is, if you can avoid that, that would be lovely. So we have some stuff we're developing in and around managing documents so that you can execute a document just once and then publish that to the actual socket. So it's sort of a two-stage publication process. We're also trying to make the most of some of the performance optimizations that that Phoenix has in and around its WebSocket thing. So for example, if you publish a JSON blob to 1 million people in Phoenix, it will encode the JSON, encode your data to JSON exactly once, and then it just pushes that directly to all the WebSockets where possible. Right. So we're trying to preserve a lot of those optimizations in and around kind of consolidating the execution of stuff. And that would actually put us several steps ahead of where most of the other languages implementations are at the moment.
Nice.
How does this relate to like observables? Like if I'm watching for data coming in, like a stream of data.
Yeah. So observables, to me, it's like a way that you might implement observing a system that is outside of what's currently going on. So in like your JavaScript land, you might have something like this text box is observable or something. And then there's like events that are happening when that text box is changed. This would be to say, hey, I want to make the system observing something that is happening elsewhere. So I give that thing a subscription, and now I'm basically like observing it. And when stuff changes, I'm getting events on the basis of those changes.
All right. So it'll push to the client then in that case.
Yes. Yes. It's push.
That is fantastic. And like absinthe too, like you could be running a static application and still call to that, right? If you have it on a server, internally.
Yeah, absolutely. So yeah, there's some interesting. We've actually been exploring a lot of the main stuff we've done with Absinthe right now is around supporting front-end, mobile, customer clients, and so on. But we've been recently exploring some interesting stuff for using it inside of like normal or Elixir to Elixir kinds of use cases or scenarios where you want to build a totally ordinary Phoenix application with server-side rendering. So for example, I am not a big JavaScript author, and if I were to go build a little website for my own use, I might want some of the flexibility and the data validations that GraphQL gives me and the flexibility of querying information, but I don't want to go build a big single-page app. So we actually have a project we're putting up this week where your views in Phoenix have a GraphQL document that says, here's the data I'm going to use in this view. And then it just like goes and gets that stuff. So you don't have, your controller is literally just like handling the I'm sending response or I have, and that's it. Like you don't have any actual data lookup there. All the data lookup's done via GraphQL. And so that's had to change. We've had to facilitate returning data types out of GraphQL that are still very Elixir native, whereas right now they tend to be already sort of along an encoding scheme. So that's something we're working on, and I think we'll have a similar thing for subscriptions where you could use it to say, hey, this Elixir application is subscribed to data from this other Elixir application, and what we get out of that is the sort of query flexibility and whatnot.
And that's related to a hackathon project I recently did with one of my coworkers. We did we took pre-render IO's GitHub, and we put that out, and then we called to a bunch of templates and APIs, and we proved out that you could do this server-side rendering template that would it would do it on that service for a static application. So you wouldn't have to have that what we call isomorphic or universal JavaScript if you had a static application. Obviously, we didn't work out the kinks and quirks in a hackathon, but it would be interesting. I wonder if it would be more optimal to use something like with the REST APIs or to use something with GraphQL to create that on that type of server?
Yeah, well, what was interesting about doing it with this Phoenix thing is that it is restful in that you've got a normal router, you've got your normal CRUD stuff, but it was using GraphQL just to say, like, I want to basically on this view get this data, and so your app felt from the outside like a totally normal, you click on a link, it loads a new page, that was a GET request, etc. But it's just using it on the inside to make your life easier, basically, as a developer. And it's a good example of the way in which it's not necessarily tied to any particular, it's not even tied to the web, like all that was happening server side, so it's a very flexible scheme.
Yeah, I like that.
Speaking of making life easier. Sometimes when we make life easier, we sort of forget the performance paradigm, because sometimes the easy things at the base level are fast, right? I can sit there and I can structure something out and get data into the view I want. But from a performance standpoint, I mean, how does it scale? Like, in terms of, to some extent, we have a pretty well understanding of how ORM scales these days in terms of the way we do things for particular types of databases. But when you stick GraphQL into the mix, I mean, how does GraphQL scale? I mean, when you start to talk about authentication of routes and things of that nature, like you've got business logic and you got the thing in the middle, and then is it prone to certain types of attacks, or the performance characteristics that one needs to think about when you implement it sort of at scale?
That's a great question. So, for example, here's an attack. I'm going to ask for this massive document's worth of stuff, and so even no matter how efficiently you perform it, a user will be able to could in theory request a sufficient amount of data that's the problem. So what's nice is that we have you can do static analysis on the query document before you execute it. So, for example, a number of implementations have a thing that basically walks the document and says, hey, this violates rules we have about how complex documents could be. Don't do that. Or make this smaller. And so there's stuff like that. Facebook knows a whole lot about scaling GraphQL. Their particular approach is that they wanted, when they actually go ship a release of something, in many cases, they basically compile out all the documents that can be generated by that application. So the developers had the flexibility to kind of make it whatever they want while they were building it. But once it's released, there's only so many documents it's actually going to produce. So they break all those out, hash them, and then they store those in sort of a repository of known to be okay documents. And so the actual application just sends the hash for that document, and then they run it. And if you send a hash to a document they don't have, it doesn't get run. So you get all no developer had to, on the backend side, say, hey, here's code to support exactly this one document. You still get all that flexibility, but at the same time, you've kind of nailed down the expectations that you have for load on your server by having a sort of known set of things that will be sent to you. So that's, and in fact, analysis of those things, you get the amount of analysis you can do on what kind of information people are asking from your server is tremendous as well. So, for example, if you have a REST API and you want to know, hey, we're encoding the author into this response. Is anyone actually using that? Like, you have no idea. Could we not be doing that? Who knows? But with this, every single field, every single label, you can analyze on how long did this particular thing take? How many people are asking for it? Are they asking for it? In what context are they asking for it, et cetera? So the insight you get into the actual load you're getting in production can help you further optimize the access. And then, as I was saying, there's ways you can protect yourself from straight up malicious attacks as well.
On the flip side of that, for tracking too, I would imagine, like, if you're just looking at logs, it wouldn't be as revealing. You'd have to have some other tool to be tracking that. But it is nice that you can get that detailed level.
Right. Yeah. There's. I know the Apollo team is working really hard on a tool they call Optics right now. That is a whole UI around and analyzing metrics on your GraphQL server. So there's a guy who's working to contribute an optics client for Absinthe so that you could use that with that and get all that information. It's worth noting, by the way, on your question about performance. So if you want to have a highly optimized, REST puts you in a position where when you write controller code, if you want it to be optimized controller code, you're going to have to write the optimizations in every one of those controllers. So GraphQL has root places that you access your graph from. And if you have some particular thing that you always want to have run a particular way, you can just go write the code to do that. But in the general case, the tools that you can provide because you know the types of everything and can do batching associated with that, the performances situations we've had, and I know that a number of other companies have had, that gets you like 99% of the way there. And if you have particular endpoints you want to optimize further, you have the freedom to go do that. Whereas in the controller case, you're constantly doing the same set of optimizations everywhere based on whatever that particular structure is. You know, you keep having to do it because your document structure is always slightly different in each of your little endpoints.
No, it makes sense. I mean, the performance characteristics of, if anyone who's had to maintain APIs, I mean, it can be very troublesome at the end of the day to make sure that you're keeping a high level of performance up when data structures change, when requirements and/or business cases change. I mean, at that point, are you spinning another version? Do you now have version conflicts? Like, there's a lot of things that, it's a lot of times we look at the surface of things and it looks, oh, this is great. But until you've dove in and done some things, like, it can get a little hairy at times and go, oh, wow, that's so easy. Or, wow, my performance is not what I thought it was.
Yeah. And once an endpoint is out there too, you can't just delete an endpoint. So now you can. It's really easy to go down the rabbit hole of adding
delete an endpoint. It's just you just delete things. This is I call removing endpoints a good day. Now for the person who used it, that's a bad day. But my day is significantly easier.
Related to that, actually, one of the things I've been super excited about looking into is I don't know if you're familiar with any of the property checking libraries in Elixir, but they are a way of, if you have a function, the classic example is if you have a function that just like takes the square of a number, right? You want to validate that function never returns, say, a negative number. You can just write like 5 little test cases with various inputs or whatever. But a property checker lets you say, hey, this function takes 2 integers as an input and will always return a non-negative integer. And then it will use generators to build 10,000 test cases that it runs against that thing. So what I've been very interested in is using a GraphQL schema to do automatic 100% code coverage of your whole API. So because it knows it can derive every possible valid document to be sent to your schema. And then you could have generators that would produce data for that. And obviously, if you're trying to create some entity that refers to another entity, that I'm not entirely sure how you would negotiate that relationship. But at a minimum, your API ought to not 500. It ought to return something. And so you could, run that against everything. Or you could build more limited test cases that say, this is the kind of, based on this input, here's the output I expect. And do that in a incredibly thorough way.
500s and 404s and good times.
Yes.
My day is not complete without at least 3 503s.
Yes.
So we talked a lot about the performance. Go ahead.
Oh, I was just gonna say it's at the end of the day it's not a silver bullet. If you want optimal performance, you're probably gonna have to roll up your sleeves and look at some particular thing. However, a number of companies are using it at tremendous scale with great success, and still able to make use of the flexibility it provides. I mean, GitHub's API is a good example. GitHub would not have exposed this API that's going to be used by millions of people if they didn't think they could, make that work in a way that I think they're confident it's going to be more performant than their REST one.
Yeah, there's a new podcast called Jamstack Radio. I don't know if you guys listen to it, but they had an episode with a member of the GitHub team. He was talking about it. It was a really interesting episode. So I'll put that in the show notes for people to check out. So for performance too, we did go through a bunch of things. I don't want to beat a dead horse?
Yeah.
But what are some good examples that people could look at?
That's a good question. I mean, obviously GitHub, we talked about them a lot. Facebook is an interesting case since they basically built an early version of GraphQL, and then they were like, boy, this is really useful. Let's make this a spec. And then they did, and the spec is now, they are working hard to catch up to the spec from what I hear. Their internal systems are slightly behind where the actual spec is. There's a couple companies that have talked to us recently about using both Elixir and Absinthe in enormous scale to the tune of some 20+ billion requests a day, but I can't talk yet about exactly who that is. So hopefully soon we'll be able to know about that. But there's a lot of interest there, and I think a number of companies that have found Elixir to be useful in production are considering it, and we are hoping to kind of support them in that. As far as GraphQL in general, it's a little hard to talk about GraphQL and performance in a super broad non-language or back platform specific way, because what doing an optimal performance looks like if you're running GraphQL Ruby is going to look really different than if you're using GraphQL JS, and different than obviously an Elixir. But
and to your point, security as well.
Yeah, exactly. But some of those patterns, I'd say the patterns that hold overall is that the documents doing kind of as much static analysis and caching the static analysis on the documents as you can is key. And I would say, as with all performance, the key to performance is measuring, and the amount of metrics that you can store on a GraphQL document is really rather enormous. And I think that that's a big step and a key enabler of making things highly performant is the measurements it gives you.
As web developers do, we make a lot of different types of applications. So the right tool for a right job. I think I did have a question of, is it ready for prime time? I think we've answered that, though. I mean, there's companies using it at scale, but in production, you've been using it for a year. Would you say that you're one of the, your company, I should say, is one of the pioneers, one of the veterans, or are there other companies who have been using it for even longer, other than Facebook, obviously?
I would say there's. I don't have any hard data. I'll start there. That's something that I did a lot of research on in preparation for our book, because they were interested in talking about the market of people for it and so on. And then I have promptly forgotten the details in the meantime. So I'll have to go. I'll see if I can do some research and email it to you. Maybe you can include it with any notes that you post or whatever on this talk. GraphQL JS is far and away the largest user base of the GraphQL spec. There's a relatively strong following in Scala. The Scala implementation is really extraordinary. They have been a great inspiration to us, and I know other implementations. The GraphQL Elixir world is really developing. I mean, we have a Slack channel, and every day there's tons of posts, and people are talking about stuff, and they're using it in production. As far as scale, I do remember there's some like broadcasting company that's using it for something, but Details and I are not on good terms at the moment. So I'll have to come back to that. Our experience with it has been very positive, and one of the more interesting aspects of that has been we actually have a customer who is using it. This is not in our domain of logistics and pharma. You get a lot of clients that are not we'll go with the most technologically experienced, because they just got like one IT guy and he wants to be able to get this thing so he can make an Excel sheet for their quarterly report or something. And because of the self-documenting characteristics of GraphQL and the tools that enables, so there's for those who don't know, there's a little tiny piece of JavaScript that you can include on a page. It's hosted by your server. And when you go to it, it introspects on your schema and provides this wonderful little UI that has all the documentation and a little like editor interface. And in that editor interface, you can begin writing GraphQL documents. And it has tab completion. It will like underline stuff if you or spell it wrong, and provide suggestions and so forth. And so and then you can hit play and it'll like show you the response you get back. So that interactive, it's called GraphQL, and we'll include a link to it. That interactive kind of tooling has made it easy for people who have never heard of GraphQL and don't know how it works really on the back end or anything, have a super easy time just building a thing that gets what they want. And so we've got people doing that.
Very nice. So it sounds like GraphQL is definitely worth it depending on your needs. I mean, for different platforms, I guess it makes more sense than others, and also for different applications. What do you think the future is for GraphQL? Like, how do you envision it with mobile, with desktop, and the web platform in general?
That's a very good question. But I want to touch on something you said at the beginning of that sentence, if that's okay, which was that it seems like it's worth it. And I think it is, but I think it's also instructive to look at scenarios where, for example, I would not choose GraphQL, because I think that helps tell you something about it. So for example, we do a fair bit of bulk data export. And so while we provide a GraphQL API that says like, hey, I want to get the data on something, if that data is like 200 megabytes worth of zipped CSV, for example, we're going to just return a URL that is like a pre-signed S3 thing that they just do, that they then go get the data from there. So it's very useful when you want to care a lot about the shape of the data and customizing that or having flexibility there. But if you're trying to give someone 2 million records or a 500,000 records, you probably don't want to. You may not want to use GraphQL for that. What is interesting though is that it is not just transport agnostic, but format agnostic in a sense. So JSON is common because that's very native to the JavaScript world. But you could return it in message pack. You could return it in really a whole protobuf. You could use protobuf to do your GraphQL query responses. There's a whole host of options there. You could use XML if you really wanted to. But at the same time, you probably still wouldn't use it if you're trying to return, say, like CSV. So there's that's just, I think, worth pointing out. It's not the one and only way to shove data around for every situation.
What do you mean? I'm going to use JSON for everything in the next 10 years.
Yes. Yeah. Yes. So the future. I've been very like heads down on where the future of Absinthe specifically is, because there's a whole lot of features we're trying to bring as far as both that are client-facing, things that we let clients do, as well as developer-focused, making your lives easier for people who are writing that. GraphQL as a whole has been. It started off very much just GraphQL.js, right, and in the JavaScript world. In the last few years, the voice of people from other implementations has gotten stronger as far as the development of that spec. And I think that's very interesting because there's actually a very strong contingent of people from functional languages who are being involved in the spec writing process. And that, I think, shows itself as far as how the spec thinks about data, changing data, and so on. So I think it's really exciting to, anytime you have a new technology that's sort of like Elixir, many people will people can like it, people can use it, but if it fails to ever get buy-in from a larger number of larger companies, it's going to remain a niche. And for some things, that's okay. But I think when it comes to a spec like GraphQL, I don't think that's optimal. Elixir can stay a relatively small language compared to Java, and it's fine. We'll have jobs and people who write it, and we'll all go on. But if GraphQL as a spec fails to become something better established, I don't know. I don't think that would fully deliver on the promise it can hold for making APIs easier to use. But I think we are seeing that kind of buy-in. I mean, GitHub was a huge step. I know of a couple other large companies that are doing that as well. And I think there's a very real possibility that this could become sort of the way that you write APIs. I think that's a real possibility.
Well, it's all very interesting to me. I like the ideas of it. I have to actually play with it in practice and see what works for our teams. But I would want to thank you guys for coming on, Corey and Ben, and always Justin.
Sure.
We are running up against time. Is there anything that we missed, maybe that web developers or developers should really know about GraphQL?
No, I personally just think it's a really exciting new technology, and I think you said it earlier, definitely worth the time to look into and mess around with a little bit.
Yeah, I think so much of it affects a little bit how you think about your data. Like functional programming, Elixir was my first functional programming language, and when I started coding in Elixir, it changed how I thought about what my code did. Now, even when I go back and I do write some Ruby from time to time, I write it differently because I think about the side effects that it produces, and I try to have my pure stuff and my impure stuff. And I think when you start writing in GraphQL, it changes how you think about the way you expose your API, because REST is so resource focused, and you tend to you think of things in terms of resources. And eventually you do that long enough, you don't even realize that that's how you think about APIs anymore. And when you start writing in GraphQL, it's just a very different paradigm. And as you start doing that, I think it changes the way that you think about APIs. And even if you decide that's not how you're going to do it, I think the experience of kind of reevaluating how you think about that stuff is critical as far as staying, developing as a developer and growing as in this space.
Awesome. If people want to find you and Corey, maybe start with Corey, what's your Twitter handle and how can people learn more about you guys?
Yeah, Twitter handle is cdspees, SPEIS. Pretty boisterous on Twitter, and I'm always lurking in the GraphQL Slack channel that Ben mentioned earlier.
I noticed.
I am Ben Wilson 512 on basically everything: GitHub, Slack, IRC, etc. Twitter. I make about one tweet every 3 years, but if you ping me, I will usually respond. And then obviously you can hit us up in the Slack channel or go to absinthe-graphql.com. It's got all of our docs and GitHub links and so on. We welcome any issues or questions you have.
Yeah, can we get a link to the Slack channel in the notes as well?
Yes. Do I do that?
Yeah, you can just put it in the doc.
Okay. I'll make sure that gets in there.
All right. I think that's a wrap. This has been episode number 118, Understanding GraphQL. Thank you guys so much for coming. We'll see you all next week.
Thank you.
Thank you.